In this video, we're going to talk about adding rational expressions. So the first thing is, what is a rational expression? So a ratio is just another word for a fraction. What about rational expressions? Well, that's a fraction expression. So it's an expression that has a fraction. And in math, when we're talking about expressions, those are things with variables like x's. And everything we learned about adding fractions still applies to rational expressions because they're still fractions. Mainly, when we're adding them, we need to get that common denominator. So we got to make sure the bottom of our rationals are exactly the same before I try to add them together. All right, so here's an example of two rational expressions. So again, there's a fraction bar and there's some x's involved. All right, so that makes it a rational expression and not just a ratio or a fraction. So we have x plus 1 and x plus 4. Again, these kind of invisible parentheses that are around these. So this is all one kind of piece, x plus 1 on the bottom of that fraction. I might think, well, if I can just get this 1 to be a 4, then they're the same. But you're not going to just change this 1 to a 4 while this x is also here. So we're going to get this whole thing to be on both sides. And just like we saw with adding fractions, I can just multiply the right-hand fraction by this left-hand denominator. Again, I have to do the same thing on the top and bottom. And on the right-hand side, I multiply by the right-hand. The left-hand side, I multiply by the right-hand denominator. And you can see in the bottom, this is going to force both of these pieces to be in the bottom. Right? So only thing we have to remember and be careful with is when we multiply this expression times the number, it has to distribute in. So we're going to get 2x plus 8 over. And certain times you want to FOIL these out, certain times you want to leave them separate. So since we don't know which one we want to do, let's just leave them separate. We'll have x plus 4 times x plus 1. On the top again, this 3 is going to distribute into both, so we're going to get 3x plus 3. And then we'll just leave these separate, x plus 4 times x plus 1. And now these bottoms are exactly the same, and now I can add the tops. And when we add the tops, just remember we're adding these together. Make sure you look for like terms. I only add together the like terms, so 2x and 3x can combine to give me 5x. Let's write that in a different color. And the 8 and the 3, they don't have a variable, so those can combine to give me 11. For x plus 4 times x plus 1. All right, so that's a final answer. We were able to combine these into a single fraction. Another answer that I would accept, the top isn't going to be any different. But if you were to FOIL out the bottom, it'd be x squared plus 5x plus 4. That's also an acceptable answer. Depending on which situation you're in, one is better than the other. So since we don't know what the kind of the purposes of this is right now, just leaving it either way is fine with me. All right, next problem. Again, these are going to be the exact same. We just have to make sure we're careful with our distribution, FOILing, all that stuff. But we're trying to get a common denominator, so we need to use this denominator over here. And since there's multiple terms, I'm using parentheses, so I remember to distribute. I'm going to use this one over here. All right, so I'm going to remember to distribute. This is going to be 5x plus 15. And just to save time, I'll leave these separate. Minus 3x minus 6. Over these separate. And again, that forces the two bottom denominators to be the same. So now I can go through the process of subtracting. One thing to be careful with subtracting, it's a little bit harder than addition in this case because this subtraction sign is applying to the whole top here. So this negative is going to distribute. All right, so we actually have minus 3x, and the minus gives us a plus 6. So really on the top, I'm not going to rewrite the whole thing just because it takes a while, but really on the top is going to be minus 3x plus 6. And we combine them across. So we have 5x minus 3x is 2x, and 15 plus 6 is positive 21. All right, so this is the only real thing you have to be careful with when you're subtracting. You also have to distribute this negative sign into everything on the top. All right, and one more example. Now we have x's on the top and bottom. It's not going to change anything. We still need to get a common denominator. The most common thing that students want to do is say, well, there's an x up here and an x here. I can cancel them. You cannot do that. All right, whenever you have addition and subtraction signs paired up with things, you can't cancel them out unless this whole thing was also on the top. So if you had something like this, where the whole thing on the top and the whole thing on the bottom are the same, that's when you can cancel. But just these x's you can't cancel because they're tied up together with these numbers. But what we do know is I can use the x plus 2 on the right I can use the x minus 5 on the left, and that's going to get me my common denominator. All right, now I have two expressions being multiplied. So again, remember there's these invisible parentheses up here too. So now I'm going to have to remember to FOIL along the top because I have two things times two things. X squared minus x minus 5x plus 5. And you could FOIL on the bottom too. Let's just leave them separate for simplicity's sake. And then plus up here again, you have to FOIL, so we get x squared plus 2x minus 4. And the bottom we'll just leave separate. And this one's an addition problem, so it's slightly easier. We just combine all like times. We have an x squared plus an x squared. That's going to be 2x squared. I have a minus x, a minus 5x, a plus 2x, and a minus 2x. If I combine all those, negative 6, negative 4, negative 6. And I have negative 6x's. 5 plus negative 4 is positive 1. Right, and there's your final answer. All right, so just remember to FOIL first, outer, inner, last to get these terms. And then you can combine them the same way we did before. Again, if you wanted to FOIL at the bottom, that's also fine. Your answer will just look a little bit different. All right, so here's the problem for you to try on your own. All right, make sure those denominators are the same first, and then just try to simplify as much as possible. I'll show you the answer in 3, 2, 1. All right, here's the final answer you get. Again, you're just using those denominators to get a common denominator. The most common mistake I would kind of expect is this minus 12. Remember, this minus sign is distributing, so you get a minus 4. So x minus 4 is negative 3. And then a minus 12 gives me that negative 12 down there. All right, so when you're working with these, again, basically all we're doing is getting a common denominator. And we just have to remember that we're distributing things, all right, whether it was like the first example when we distributed a number in, the third example when we're FOILing out. All right, just remember to do your distribution methods when you're doing and working with these rational expressions.